G'day frothers, welcome back, and today we're going to be taking a look at something super interesting to, well, some of us, but super important to pretty much any climber out there, and that is one of the engineering standards that governs our safety equipment, specifically EN959. EN stands for European norm, and so it's been published by the European Standards Institutes. If you're not in Europe, you can still reference it if you like, you can still buy the gear if you like, and in fact, for that reason, it's going to be the main safety standard governing recreational rock climbing fixed hardware. And if you've ever wondered why the bolts you're clipping have all this stuff written on them, this standard is, well, one of the reasons. Now, I am going to be discussing the whole standard in here, and I'm going to be showing most of it as well. Now, you're not supposed to do that. This sort of stuff is copyright, but I'm doing this as a good faith educational exercise. So any Standards Institute people out there, you know, if it really bothers you that I'm showing all this stuff, just let me know and I can take it down, but I will beg you, please don't, because this sort of stuff is the cornerstone of rock climbing safety, and it's something that millions of climbers all around the world trust their lives to every time they tie on, but they have A, no idea what it actually says, and B, will never pay in a million years to buy their own copy. So now that's out of the way, let's take a look at what it actually says. Alright, so let's dive in. There's your contents. Forward. So this has a bit of a change log in here. So compared to the old version, they've changed a few things. Probably the most interesting thing is this material. So they've got corrosion stuff in here now. Bit down there as well. Introduction. So this basically all started with the UIAA. It started with rock climbers, not with, you know, the European government trying to tell rock climbers what to do, but the rock climbers actually saying, hey, let's try and get real proper standards going for all this kind of stuff that our lives depend on. So, people power. Okay, we got scope, we got some definitions, blah, blah, blah. Take a look at all those if you like. Now, materials. This is new stuff for the 2018 version. So, straight off the bat, we've got some great stuff here. Don't mix metals. Don't use polyester glue. So that's like the weakest kind of the three main types of glue. Be aware of different kinds of corrosion that might be happening where you're installing these. Alright, table 1, straight into the good stuff. We've got the kind of material you need for different corrosive environments. So class 1, basically your titanium. So that's where stress corrosion cracking is going to happen. So that's if you're in Tonsai, Cabo de Roca, places like that. Normal kind of outdoor environment, so that's going to be your 316 stainless steel. And then indoor use is basically your plated steel, that kind of stuff. Except if you're near a source of corrosion like a swimming pool. All right, next up is the design. So they talk about how big the eye is, how thick the metal has to be, rounded corners, that sort of stuff. And we'll see that down here. With the eye, it's got to be able to fit something that's 11 millimeters and something that's 15 millimeters across through there. So if you've got two rods or pins, you can stick them through. And that's basically saying, you know, it's going to be big enough to fit a carabiner and maybe some other things in there. So that means your hardware store eye bolts, they're out. Okay. The eye is not big enough. Not okay. They're big on the sharp edges. They do require a certain edge diameter, so you can't have sharp corners on this stuff. And then here's a cutaway. So thickness, got to be a certain thickness, got to have a certain radius on there as well. So no sharp corners, and this is just the text for those diagrams. So basically when it's installed, the eye's got to be big enough to fit stuff through it. Now, this is a good one here. Shall not be dependent on contact with the bottom of the drill hole. So that's your drop-in anchors and a few other styles. They are out. Great one. Now this is one of my favorites. For glue-ins, we've got to be at least 70 millimeters long. Now, before I started doing pull testing, I thought that was a little too short, but I've had plenty of strength out of shorter bolts than that. So these guys have done their homework. For mechanical anchors, the installed length has to be 5 times the diameter of the drilled hole. And a little note, which is awesome, in soft rock, you may need to use longer bolts than that. And this is another great one. If it's like a chain anchor, the whole thing has to be rated to 25 kilonewtons. So for a chain anchor like this, it's got to be end to end, the whole thing, got to take 25 kilonewtons. So you can clip into any part of it. Another great point here. So if it's a rope attachment point, it's got to be at least 9 millimeters thick, which is why most rings you find are going to be 10 mil. Some of them are 8, and unfortunately those guys aren't actually going to comply with this standard. So that would comply with the 2007 version, but not the 2018 version. And don't mix metals once again. All right, so load bearing capacity. So axial pull, it's got to be able to take 15 kilonewtons without being pulled out or breaking. And this is an interesting part. Deformation is permissible. Now, obviously with rock climbing bolts, we don't want deformation. So this is why you want to use a bit more of a safety factor, because if you've got like a little 8mm bolt, maybe it can take 15 kilonewtons axially, but then it will be deforming at 5 or 6. We don't want that. We want to have a bit more headroom for our anchors, so that's why we'll basically use bigger stuff that's not going to be deforming. Okay, so radial pull, this is so-called shear, 25 kilonewtons. And then this next part, all the parts of the anchor need to be 25 kilonewtons. Now, test methods. How do we actually test this? So the manufacturer has to prove that they've actually done the testing in accordance to this. Then you're actually going to need a concrete block. So 20 centimeter cube at least, and a compressive strength of 50 MPa. So I usually use 32 MPa, but you can get 55. And this is an important point. If you're going to be doing your own tests, the aggregate shall not exceed 16 millimeters. So be sure to get fine aggregate. Compressive strength of the concrete block shall be verified on 3 samples and according to another standard. And basically if you want to do this kind of thing, it's much easier to just go get a concrete testing center because they make this sort of thing. So how are you doing the test? I mean, check your setup, install the bolt, and then the testing procedure. If you want to do this, the interesting thing for me is they actually do apply a load of 8 kilonewtons first. I've done this kind of testing before. It is a bit of a pain, but it's really interesting because that's showing this sort of cyclical loading that your rock climbing bolts are going to be experiencing. They're probably not going to get 8 kilonewtons, but normal bolts are made for construction. They're made for static loading. You build the house, you put up your railing, whatever, and then it just stays there. With climbing loads, you do get cyclical loading and things can loosen with that. And once again, I like this because it's showing that this is really rock climbing specific anchors. And there's a picture of the axial test. So pull upwards 15 kilonewtons. And here's the radial test. So basically the same procedure, install a new rock anchor into a new concrete block. So that's pretty important, I guess. I'm glad they pointed that out. And then if you're pull testing a chain anchor, you pull the entire thing through the eyes of the hangers. All right, so marking. So to comply with this standard, you've actually got to say you comply with this standard, which is great, as well as a bunch of other stuff. So name of the manufacturer, serial number, anchor class. So that's your material. That's why it has the little 2 in the circle here. And that's why Fix Hardware finally changed to using 316 stainless steel after years and years of using worse stuff. Because they had to if they wanted to comply with the new version of this standard. And then it's also got to have this little thing that says read the manual. So that's, believe it or not, this is actually required to comply with this standard. It's got to have the little read the manual symbol. And of course, that little symbol there is number 1641 from ISO 7000. So that is a specific symbol designed for this purpose as required by another standard. Love it. Information. So it's got to refer to the standards that it complies with and how to install it and blah, blah, blah. Little bit more info for the manual down there. So Annex A, this is all these other standards which cover mountaineering equipment. Annex B, this is just about environmental conditions and corrosion and stuff. So this is Annex C. They're talking about stress corrosion cracking. So these are, chloride's obviously the main thing you've got to worry about. But then all this other stuff, like it's not mentioning sulfur at all. No sulfur reducing bacteria. This is relatively new information that has been basically discovered by Dave Reeve over at cragchemistry.com. So go check that stuff out. It's super interesting. And it explains why specific areas will have bolts that literally just crumble under your carabiners and other areas don't. And this table, this is good because it's in the newer version of this. It wasn't in the older version of this standard, but it's also not referencing the cutting edge information yet, because that's not what standards are for. Standards are meant to describe the well-established, well-demonstrated, proven conditions that things are working in, and the whole sulfur-reducing bacteria thing that Dave has recently discovered, it's still pretty cutting edge. And then this is the stress part of stress corrosion cracking, is actually the stresses from manufacturing, creating little cracks or little voids or whatever in the metal, and that's where your corrosive stuff can get in and start causing problems. Annex D, so this is the kind of stuff that us bolter, YouTuber sort of guys bang on about all the time. Basically, you need to know your own rock, you should really do your own testing, that kind of thing, you know. I mean, you can refer to a standard, but at the end of the day, you need to actually make sure you're doing what's right for your own rock. So, you know, if you're using an expansion bolt that complies with this standard, in soft rock, then, you know, that's obviously not going to work. So this wedge bolt in this sandstone might actually comply on paper, but the rock is obviously too soft. So here they're saying, look, you still need to do your own work for your own situation, which is always gonna be the case. Well, there you go. Hopefully that was interesting. Hopefully at least now you know why these things that we clip and we trust our lives to have all this stuff written on them. But if you've made it through this whole video, then chances are you do actually care about the bolts you're probably installing yourself if you're watching this channel, but also maybe clipping too. But do you as a bolter need to worry about following this exact standard? Probably not. It'll really depend on where you are and what your situation is, but chances are there's nobody enforcing it at all. If you're somewhere like Queensland where I am, you may need to apply it in a few situations. For instance, rock climbs in national parks have to use EN959 compliant hardware. And that's actually something that the local climbers lobbied for to get put in there, because it's a way of A, getting climbing properly recognized as a legitimate activity, and B, holding up our end of the bargain to the land manager saying, look, we're not just a bunch of total yahoos. We are working to a safety standard. Please just let us, you know, self-manage the climbing hardware, and rest assured that, you know, it's not going to blow back on you. It's not really going to cause problems for you, and you don't need to worry about it. In fact, I've been in meetings with land managers who are getting nervous about newly developed rock climbing happening on their land, and the relief is palpable when you actually mention to these guys, yeah, we are bolting to an international standard. It really helps to have some kind of technical document like EN959 that you can point to and say, these are the kind of standards that we're bolting to. If you want to do a bit of testing or do some safety reports, or, you know, you've got some engineers in the area who are also climbers who can chip in a bit of knowledge doing some risk assessments, all that kind of stuff really helps. And that's part of what access clubs do in the background. If you're just a regular climber, you just go out climbing and you enjoy it, then that's great. But, you know, you should really be aware that a lot of these places that you climb in, whoever owns that land, whoever's managed that land, has probably at some point tried to shut it down due to safety concerns or liability concerns. And the fact that we can point to this international standard, even though it's European, even though you're not bound by it, you know, it really does help. And then within the context of us, the sort of rock climber bolt guys, you know, some of us on YouTube and elsewhere who are doing like bolt testing stuff and bolt mechanics stuff, for us, it's really good to be able to point to, you know, the minimum standard for this is 25 kilonewtons. So anyway, Frothers, thanks for watching. Happy bolting, happy clipping. And, you know, I know this is really esoteric stuff, but this is all the kind of shit that I wondered about, you know, 10, 15 years ago when I was getting into bolting myself. And hey, happy to do it. And once again, if you're a Standards Institute person, you know, please don't make me take this video down. Anyway, scratch yous later.